Boy, that copper really grabs the center drill when it starts to break through. I'm sure that won't cause any problems in the next 19 minutes. Hello Internet, my name is Quinn and this is Blondihacks. I'm back on my Fire 2 boiler build today, and I need to make a whole bunch of radial features in the boiler shell. That means I need a radial setup, and I think this is going to be pretty interesting. So let's go. Here's my goal for today. I want to take this boiler shell and put a whole bunch of fancy holes in it. That row along the bottom are vent holes for the gas burner, and then there's a U-shaped slot there for the gas burner as well. And then there's a pattern of 4 holes up above, 2 of which are water gauge, and the blowdown valve also goes on there. And then there's one for the pressure gauge and a check valve for boiler feed pump access. And then there's some miscellaneous holes. There's mounting holes around the bottom, and then there's 2 rows of little rivet holes, and the tube plates are going to go here. The tube plates are not going to be riveted in place structurally, but I am going to use rivets to hold them in place during silver soldering. Before I do anything though, I want to address the squishiness of this pipe. It's not very round, as you may recall from previous videos in this series. So I found the widest point, marked that, and then I checked around a few other places, and if it's only squished on one axis, then 90 degrees off of those marks should be the narrowest point, and it was. So I did the same check on the other side, make sure the marks are all in the same place, and it looks like I can just squish it on this one axis and I'll be good to go. I put an indicator on there to measure how much I'm squishing, because there's going to be springbacks. I want to be scientific about this. I want to squish a certain amount and then see how much the size changed. And then from that I can calibrate my future squishes. So it looks like about 20 thou of squish nets me about 3 thou. Using that method I was able to get it within 5 thou of being perfectly round, which is a vast improvement on where it was, and will be close enough to where I can silver solder the 2 plates in there without difficulty, I think. These are all radial features, so we need a radial setup. I'm going to use this vertical rotary table setup with a chuck mounted on it. Regular viewers have watched me spend quite a bit of time building this fixture, and now you know why. Many of you guessed it, in fact. So I'm going to start by squaring it up on the table roughly with a square. That'll get me within 5 thou, and then I can bolt that down and put an indicator on the back. I've got my half thou dial test indicator here, and I'm going to use this to get the table square. So I just run it back and forth and then tap it in until that's running straight, or, you know, sufficiently straight. It's within half a thou now over basically the width of the table, which will be sufficient. And then I also checked it vertically just to make sure. This is a high quality Vertex rotary table, so it shouldn't have any issues with verticality here, but there might be a chip under it, or there might be, you know, some other thing causing it to be crooked, but it looks like it's going to be fine there as well. And then, as you saw in my previous video, I spent a bunch of time squaring up the tailstock in a silly fashion. Go watch the video on making this Footstock Riser block to see how I should have done this better. I installed a test bar here between the footstock and a center that's installed in the rotary table inside the chuck, and I tapped it in horizontally. And then I used the height adjustment on the footstock to get it aligned vertically. And then of course you have to check the other axis again. Every time you move it, something else might have moved, so you gotta go back and forth until everything stays perfect. Sprocket, get away from the microphone. The last time I showed this setup, a lot of people asked, how do you get the bar out? Well, this is how. The footstock has a little quill on it that you can retract and remove the bar and install the workpiece, which is gonna be this pipe, as you may remember from moments ago. I decided to mount this over the jaws of the 3-jaw, which I will expand into the pipe to hold it in place. And then I'm going to install this mandrel on the other side, which you may have seen me make when I faced the ends of this pipe. Part of the reason I spent so much effort making this fancy mandrel was because I knew I was going to need it here as well. So I'm just double checking that the mandrel is going to be in a position that's going to miss all of the holes that I need to drill. And I got to put the stub shaft in there. And this setup uses the shoulder on that stub shaft as opposed to in the lathe where I had it in the Jacobs chuck. So this time I am going to use the shoulder, but I only need light pressure on that mandrel. And then the footstock can use the center in that stub shaft for support. And that is looking pretty good. Now that was a lot of effort to build what's basically the world's slowest lathe, But this was something I wanted to try because I've never done a radial setup like this, and I wanted to practice doing it even though this level of precision is absolutely not necessary for this. You could definitely just do this on a drill press, mark out some holes, and you would be fine. But I wanted to try this, and it was fun. To center it up, I decided to use the stub shaft there because the pipe is too big to get my edge finder around it. Another option would have been to use the ruler trick where you pin a scale or something straight to the top of the round surface. And when that thing is horizontal, then you're basically on the center line of the round surface. And then I found the edge of the pipe there as well. All of the features on this part are in basically polar coordinates, essentially. They're all positioned with a distance from one edge and an angle. For the first set of holes, I did a dry run with a Sharpie marker, roughly where the drill would go, because I don't have a lot of experience using rotary table setups like this, so I wanted to make sure that I wasn't going to have an off by one error or something like that. But that looks like it's going to work, so time to make some chips. I got the center drill out, and I'm going to start by center drilling all of my marks. So this is 11 holes on a 12-hole spacing, because one of the holes is where the rounded slot goes for the burner to stick through. For measuring the angles, I just used the markings straight on the rotary table. I actually do have dividing plates for this rotary head, but even for me that was a precision bridge too far. Again, we're just drilling holes in copper pipe here. They don't have to be that precise. So just eyeballing carefully the center of the markings there on the rotary table was sufficient. So I center drilled all of them, and this was going okay. You know, copper has a reputation for being kind of ornery to drill, and so I was a little concerned. The center drill definitely complains quite a bit, and that should have been a warning for things to come, but I did not heed it sufficiently. The other recurring theme here on this setup is vertical space. I'm using a collet for the pilot drill here because I don't have space for my Jacob's chuck in there. This is quite a tall setup, and vertical space limitations would plague me throughout this entire job, but luckily I did have room for my pilot drill. Anywhere that I can use drills for which I have an R8 collet, that works just fine, but there are some upcoming operations where I won't be able to do that. Whoops, missed one. For this row of holes around the bottom, luckily I can just stick to standard drill sizes, so I've stepped up in a couple of sizes to my final size here of 1/2 inch, and these holes are just vents, so they don't have to be precise, so I can get away with just drills here. And this went fairly well, just stepping up in a few sizes to keep from getting bitten by this copper. Copper is kind of the worst of all worlds. It's gummy like aluminum, but it's sticky like brass, so it's hard to cut cleanly, and it grabs the tools and pulls them in. I found a slow feed and a little slower RPM than you would normally use works well. Onto that slot now. I decided to pre-drill it because I don't want to have to do too much work with the milling cutter here. Again, this being copper, and this is type L copper pipe, so it's 110 thou wall thickness, which is pretty thick for a single pass with a milling cutter in copper. So I'm using drills to ease the burden here quite a bit on that cutter. Now I'm going to come in with a 2-flute 1/2 inch end mill, or a slot drill as the Brits would call it, and I'm going to plunge this straight down to bring the top of my slot out to dimension and create the rounded top that I want on it. And then I tried just feeding straight over from here, but the mill was chattering and vibrating like crazy, so this was too much work for it. That was just not going to work. Instead, I pulled the cutter back out and plunged down in the middle there one more time between the drills and cleaned out the bulk of that material that way. It was much happier plunging through this material than side milling it. So once that had been plunged out, then I could come back in and side mill the edges to clean them up and bring them to dimension. Again, precision is not super critical here. This is just a slot that allows the gas jet to poke out through the base of the firebox and allows the gas line to be connected. Now I knew I was going to get very close to the face of the chuck here in order to complete this cut, so I put a piece of paper in there, and if the paper gets grabbed and pulled out of my hands, then I know I shouldn't get any closer to the face of that chuck because I'm going to gouge it up. Next are the mounting holes for the bottom of the boiler, and this is a 3-hole pattern, and again I wasn't super confident in my rotary table skills, so after marking the points with Sharpie on a dry run, I checked with string to make sure that the spacing between them was correct and that they were going to end up centered on the slot there for the gas burner. I just want to make sure this is aesthetically going to look nice when I'm done, and it seems like everything is working out as I'd hoped, so I went ahead and center drilled this. Now, I think I got lucky on that first one, but on the second hole I realized that actually I'm very close to that chuck jaw, and I should probably make sure I'm not going to hit it with any of these drills. So I put in a mark on an Allen wrench there for how deep the hole is relative to this opening here, and I put that wrench in there and I was able to just feel around for where that jaw actually is and make sure that I'm not going to hit it, and it looks like I'm just barely okay there. So kind of got lucky there, and well, I will take it. Next up was going to be the clearance drill for the number 10 mounting hardware, but there is just not room in there. I could not get the drill in, and a clearance drill for a number 10 bolt is not a common collet size that I have, so I need some other approach. For just such occasions, I keep an emergency set of cheap import drills that I don't care very much about. So I grabbed one of those that was the correct size, and I just cut the end off it to make it a little shorter. It was very close to fitting there. I only needed a little bit of leeway, and I still, amazingly, do not own a set of screw machine length drills, which would really be a good investment for this small mill. But in a pinch, lopping the end off a cheap Chinese drill works just as well, and now I'm able to get in there. Now these are not very good drills. You can see that it's not even cutting very straight there, but again, these are just clearance holes for the mounting hardware, so that'll be sufficient. Next up are the 2 rows of 3 rivet holes that hold the 2 plates in place during silver soldering. So these get center drilled as per usual. Now what's interesting about these is that these copper rivets are going to go in there, and these are 1/8 inch diameter, and these need to be a very good fit in order to expand properly and hold tightly. So they need to be reamed, so that's kind of interesting. So I'm drilling 1/64 under the Reamer size, which is how you do it in Imperial. And this was just fine, except when it came to the reamer, my reamer was too long. And once again, it has a weird shank on it, so I can't put it in a collet. No room for the Jacob's chuck. A quick sidebar on reamer length challenges on small mills, because people always ask, well, why don't you just cut them down like you would with a drill? The reason that I'm hesitant to do that is because reamers have a center in the back of them, and the center is very valuable. First of all, if you ever want to regrind that reamer, you need the center, and there are also setups on the lathe that you can do using that center, so it has value. So I'm always hesitant to cut it off, because once you've cut off the original center with which the reamer was made, it's gone forever, you can't get it back. I thought about this for a long time and ultimately decided, you know, I'm never going to regrind a cheap Chinese 1/8 inch reamer, so I'll just cut the end off of it and I'll buy a nicer one next time I need a full-length reamer. Now you can also buy short reamers. They're called drill length reamers, at least so I've heard. They are very difficult to find, so I don't have a set of those either, but those would also be a good investment for a small mill. I should note that I'm doing all of these cuts dry because all of these surfaces are going to get silver soldered, and I don't want any kind of contamination with any kind of cutting oil or anything. Quick test fit with that rivet, and that is an excellent, excellent fit. So that is going to rivet on there very, very nicely. And I'll check that one more time at the end because it's super satisfying. Man, that's really great. I love rivets. They're super fun. Now comes a bigger height challenge, however. I need to put 4 holes here and here. They need to be fairly large and precisely dimensioned because they are for boiler bushings. So I would like to use a reamer for that, of course, but this reamer is much too tall. And, well, the shank on it is, once again, a weird size for which I do not have a collet. Even if I did, though, you have to, of course, pre-drill under size before reaming, and the pre-drill size for reamers is always also a strange size, for which I do not have a collet, and the drill is too tall to fit in the Jacob's chuck. So the pre-drill is often the bigger problem when trying to ream in limited vertical space like this. Another option would be the boring head. I can pre-drill with a smaller drill, just big enough to get the boring head in here, and there is enough vertical space here. So if this absolutely had to be a precisely dimensioned hole, the boring head would probably be the way I would go. However, the truth is I control the dimensions of both of these parts. So what I can do is just come in with a basic 3/8 drill, which is going to drill a little bit oversize, and then I can just make the boiler bushings a couple thou oversize so that they're still a good fit. So in this case, it was easier to adjust the dimension of the mating part than it was to make the hole the exact right size. Okay, great, problem solved. I can center drill these holes now, and yeah, these center drills are still fighting me a little in the copper, but it's fine. It's all going to be fine, right? So I did the other 3, and then it came to do the second last one, last hole on the entire boiler, and oh no. Yep, there's now a nice big old piece of high-speed steel stuck in my boiler shell. Now, I can't leave it in there and just move the hole because that has compromised the structural integrity of the material, of course, and this is a pressure vessel, so I gotta get it out of there. Digging it out of there with a pick didn't work, couldn't be that lucky, so I'll stew on this for a bit, but in the meantime, I will drill the other 3 holes here that I have set up. And I'll let future Quinn worry about the broken center drill. So once again, I pilot drilled and then drilled these out to final size. Again, using a drill, they're going to be a little oversized, and I'll adjust the bushings to compensate. To get that broken drill out of there, a viewer a while back sent me this set of diamond burrs, so I thought I would give this a try first. I got the vacuum set up there to keep diamond dust off of the equipment, and I'm going to try and grind that chunk of high-speed steel center drill out of there. And this was working pretty well. I was able to grind down most of that chunk until it got too deep and the burr was starting to jump around. However, I have this old carbide scribe that has a dull end on it, and I can use it as kind of a high precision punch, and I can possibly just punch that chunk of drill straight through once I've ground out the top of it there to get it kind of unwedged. And that worked. Yay! Standard Imperial victory dance. The operator is pleased with that result. Well, that was a relief. Now, let's see about drilling the hole. All of that hammering and grinding has shifted the center, so the drill is moving quite a bit. I don't think I want to try drilling this out because the drill is going to end up moving off course, and also there's still maybe a stray chunk of high-speed steel in there, which is also going to make the drill wander even more. So I don't want to end up with these 2 holes out of line because this is for the water gauge. So instead I decided to come in with a 1/4 inch 2-flute end mill and plunge this straight down to make that hole. An end mill is much more rigid and will stay on course much better, and this being carbide, if it encounters a little bit of that high-speed steel in there, it can take it a little bit better. The end mill is vibrating quite a bit, so there is, I think, some chunks of drill still in there. But once that's done, I'm left with a 1/4 inch pilot hole just like the other ones, and so now I can come in with my 3/8 drill, and the pilot hole is the same size, so the drill dynamics should be comparable, and I should end up with the comparably slightly oversized hole as with the other 3. And now I know it will be perfectly in line where the DRO says it should be, so that my water gauge will hopefully fit. With that, I can fish the boiler shell out of there because we are done with all of the drilling and cutting and so forth. That setup there was a lot of fun. I'm really glad that I took the time to do that. It came out really well. And while the inside of this boiler shell is now a frightful mess, as you can imagine, but the mandrel there did its job like a champ as well. Got a big deburring job here. I'm going to have to bust out every trick I've got, I think. So for the insides of the big holes, I'm using this hook-shaped Noga blade. And for the outsides of the holes, I'm using a straighter blade. Deburring the outsides of holes on convex surfaces can be a little tricky, so a single bladed tool like that works well. For the smaller holes, I'm using my collapsing backside deburring tool from Noga again. Links to all these tools are down below. I show these tools off quite a lot because I adore them. For the fronts of the small holes, I'm using this style of deburring, which works okay on these convex surfaces if you just sort of rock it back and forth. And then I've got this little tiny version of the collapsing tool for the small holes. Then back to the straight bladed tool again for the oblong shaped slot there. Deburring copper can be kind of ornery. It doesn't like to give up its burrs, it really hangs on to them. And then there's a couple of corners there that I can touch up with a needle file. But with a lot of fancy carbide tools and some elbow grease, it's looking pretty snazzy in there now. So there's the basic shell now all drilled. You can see how it's going to look next to the engine there. Making all these fancy holes was actually a lot of fun. I really enjoyed that rotary setup. That was something I've really wanted to try on my mill. And well, here's how it's going to look behind the engine, which is more how you will see it. Overall, I'm really pleased with the progress so far on this boiler. So thank you for watching. I hope you enjoyed this. If you like these videos, maybe you throw me a little love on Patreon there. There's a card there on the screen. The patrons are really the only reason these videos continue to exist. So if you like this content, do me a solid, vote with your wallet. Really appreciate it. Thank you for watching, and I will see you next time.